DNS. DNS stands for Domain Name System, and it's a network service that translates names into IP addresses that computers can recognize. For example, this is John, and this is John's phone book. Every friend of John has a phone number associated to his name. As a comparison, DNS serves as the phone book for the internet, meaning websites like Yahoo, Facebook, or Google will be translating to a very specific string of numbers called IP address. In this project, we use DNS as a channel for malware. We want to compromise a computer injecting a malicious code in there and send instructions to a target machine. Now that the target machine is affected, suppose that the user needs direction to google.com. The target machine will request an IP address for the DNS server. If that name is stored on the DNS cache, it will map to an IP address, and finally the user can access google.com. But what the user doesn't know is that we keep track of every movement in its computer, and the malware starts to act as soon as he opens a browser. And at the same time the target machine is making trustable IP requests, the malware is making malicious requests to the DNS server, receiving commands to extract files or any output. And all the process is being controlled from the DNS server that acts as a command and control server, sending those commands back to the victim's machine. In the first stage, we make the DNS server listen to a new or a returning response from the malware, so we can keep track of them in our interface. When a target machine starts, the malware starts as soon as the user login, sending the MAC and IP address of the target machine to the server, which creates a specific folder for that victim. Now let's see what it can do. We have our server on the left and the possible victim on the right. Let's send a list directory command to the malware. A file just popped up in the server and is the directory listed on the right screen. Now let's steal a file, send its name to the malware. Another file just appeared in the server, and it's the very same file from the victim's screen. This is a Wireshark login. It's very difficult for the victim to find out that it's being attacked. The malware can execute at any time, and its packets can be hard to find among thousands of packets that other applications are sending and receiving.